of the Arduino and why we need the Arduino in our life, in our daily life as well as in the industry. So we get a overview about that, and I hope that you also enjoyed the video I have shared in WhatsApp. So let's start with more deep into the detail. Let's dig into the detail and let's write some program on it, and let's know how about the Arduinos. So first, before going to the detail, I want to tell you some major concept of the Arduino. That is the very basic concept. Although there are several things are there, several different advanced things are there, but the start with we know 6 major concepts. These are digital write, analog write, digital read, some functions, statements, if else, analog read, and serial communication. We will learn one by one in detail. I think who are from, all of us, if I am not, we are not, I am not from, someone is not from electronics and electrical background or computer, but he or she also may heard about digital or analog signals. So digital is a kind of thing, so it is represented by 1 or 0. Okay, and in digital, in analog, in analog domain, that is a continuous signal. So how can we implement the digital signal with Arduino, or how can we play with the digital signal in Arduino? So there are specific commands for that. That is pin mode. So this is the specific command, pin mode, pin and mode. I will tell you what when I will show you that how can we use this command in our programming. So but just for time being, let's just consider this as a syntax, and this syntax may be expressed as pin mode, pin comma mode. And here the pin means the as a input or output. For example, what we means for the for analog input and digital input. See, A0 to A5 was the analog inputs, and whereas digital input outputs are this 2 to 30. So in which pin I want to play with? In which pin I can in which pin I want to give the data or take the data from the Arduino board. So I have to specify that pin, and that command is p comma mode. If I want to read a data from a pin, so that is digital read, and this is the pin number. Okay, pin number may be from 1 to 30. And similarly, digital write means I want to write some data to somewhere over else, and I want to give some data to somewhere over else. So that is the write. Read means I want to take the data from the sensor. Write means I want to give the data to the actuators. So this is the kind of very simple syntax or command you have to understand, or just you can use this, you can by using the library, you can this programming, these commands are available in the library. You can just copy it, paste it, but you have to learn the thing where I can do what. And for a programming, so if I want to take a data from some sensor, so here digital right. So this is the kind of introduction to the different syntax which are available for the Arduino. Okay. Now coming to the this is the typical analog signal, you know that, and if I sample the analog signal, I can get the digital signal. Fine. And there is some specific specification about this signal for the sampling. That is first comes in our mind, that is the resolution. What is the resolution? Resolution is the minimum level that can be measured uh, uh, for in resolution. Number of bits, there is 10 bits. And again, actually 1024 steps in case of, right? So if you calculate this in 5-volt range, the minimum the resolution of the Arduino board is 48 millivolt. What does it mean? It means if there is same which, and for example temperature sensor, the resolution of that sensor, if the resolution of that sensor is less than 4.8 millivolt, in that case input, I mean you can't get any signal, generate any output signal from the Arduino board. Okay, so Arduino can't recognize that signal. So you have to keep in mind that the lowest resolution, lowest voltage measure that should be. So what you can do, you can use amplifier for the sensor or any signal conditioning circuit. So that will help you to increase your voltage level. Fine. And the this is the specification. The maximum sample rate for the Arduino board is 1000 times a second. Sampling speed. So why we need sampling? Sampling means if you digitize a analog signal, for that purpose you need a sampling, because this is a very, I mean, there is a kind of thing you don't I mean we don't want to go into the detail because this is not the purpose of our study. So this is, I mean, typical peculiar electronics thing, that is when you want to digitize a analog signal to a digital form, then we have to sample it, and the sample speed for this Arduino board is 10,000 times a second. Okay. Now come to the part of the analog out. So we can take the digital input, we can give the digital output. I mean, you can in the Arduino board, you can take digital. Yeah, by using uh, you can get the, say for example, 4 to 20 milliamp input. This is the analog input. Now, for example, so but it is also give you, it can give you the analog output also. But some what happened if you want to give this analog output in terms of digital form. For example, you have a LED, okay, so, and you want to glow this LED as per your, I mean, convenience or as per your mood. For example, if you want to read something, so what you want to, what I mean, if you want to read some story books, so you don't need high brightness, you need smaller than that. So for if you consider the case, second case, that is if you want to see some movie in your room, so in that case you need very low light condition, for example 25% brightness, full brightness. And when you are working or when you are cooking, you need 100% brightness. So how can you change this brightness of a LED bulb or LED, any kind of LED appliances like LED tube light or anything you have in a smart bulb. So to do that, what you can do, the Arduino board gives you a facility that is known as the pulse width modulation. So once again, I am telling you, as we are from the various background, various field, don't go into the detail, but take the essence of the features. So that will help you to build in your particular case, in your particular application, in your field. So pulse width modulation once again is a kind of electronic thing. So what does it mean? Take the essence from it, take the glimpse of pulse width modulation. So what I told you that I have a Arduino board, and that can give me analog output, and that analog output is also in terms of digital one. How that possible? That is possible by using pulse width modulation. So let's understand what is pulse width modulation and how can I get a digital output from a analog pin. Okay. Now, pulse width modulation, if I give you a statement before going to that, it is kind of something like that. In some, I mean, if I remember in some different fair kind of things, I mean, मतलब क्या होता है कि हम लोग जब मतलब कोई भी अगर कोई पता अभी होता है कि नहीं पता, लाइटनिंग जो होता है, सो लाइटनिंग मतलब मेले में जो डिफाइंड काइंड ऑफ लाइटनिंग दिया जाता है, तो उस लाइटनिंग में क्या होता है कि डिफाइंड काइंड ऑफ लाइट ब्लिंक करता है. दैट मीन्स द ब्लिंकिंग ऑफ दैट particular lead or light that can be controlled by a circuitry. That circuitry is very basic level, and that's recruit level circuitry. But what we mean to say is that the blinking or the brightness of the lamp can be controlled by a circuitry. How? That, see, for example, you have a 5 volt. So you have a 5 volt constant supply. This is time, this is voltage, and you have a 5 volt constant supply. If you give this 5 volt to a bulb or to a LED bulb, it will glow. If it percent brightness, will be there. That will be, if I say for example 1 volt, so that may be 1.25 volt or less than that, around 20 to 25%. So what I can do is that instead of giving full voltage, I can give lower voltage than that. So that is known as the digitization of the analog signal. I mean, in this particular pulse width modulation case. So how can you do that? By simply I mean, modulating the duty cycle. Duty cycle means what? So that's why it comes to the modulation. Pulse width. So this is, if I consider this 5 volt case, so what is the pulse for the 5 volt? For example, if I want to give a pulse for 5 seconds to this bulb, so what is the pulse for this 5 seconds? That will be what? That will be full 5 volt per 5 seconds. For example, I want to I have a bulb and I want to make it glow for 5 seconds with a 100% brightness. So what I can do, I can a 5 second to it, and
Sir, your voice is breaking.
is constant. Yes. Hello, am I audible?
Yes, sir. Now audible.
Audible.
Okay, just hold for a minute. I think now it is okay. Is it okay now? Hello. Hello.
Yes, sir. Yes, sir.
You are audible now.
Hello.
Yes, sir.
Okay. So let's start the class once again. So if I break it, something like that. To so what is our aim? Our uh, aim to glow the bulb with 5%, 50%. Sorry. So I will break this 5 volt in this way. So this is the total. Just hold for a minute. So what does it mean? It means is that I am giving the 5 volt. So total cycle is divided by 2 parts. Okay, just wait for a minute. This is a mistake. So you can, so total this is 5 second and this is 2.5 second.
Sir, you are not audible.
He is on mute. Hello. Hello. Sir, you are on mute.
Is it now clear?
Yes, sir.
Okay. So what I am telling is that if you want to glow this bulb in with a 50% of brightness, what you will do? You can break that. I mean pulse. You can break that signal something like this way. That is in 50% of time. That means 5 seconds. The 50% of that means you have to give the pulse of 5 volt, and the rest of half you don't have to give any pulse. That means in this particular portion the bulb will glow, and this particular position the bulb will off. Now take a situation where this 5 second is very less, I mean less than 1 millisecond. So our eye can't recognize that bulb is off. But what can recognize? Because the blinking and I mean switch on and off, I mean switch on off means the glowing part and the off part is so fast that our eye can see that the bulb is glowing, but that is the brightness of the bulb is reduced, and that is 50%, because we did that. Now similarly, by modulating your pulse means the on time and off time. What is duty cycle? Duty cycle means the on time plus off time. That is T by T on plus T off. This is the duty cycle. So by modulating this duty cycle, you can adjust your brightness. So if you need more glow, so what you have to do, you have to go for, so T on should be greater than T off, and if you get a, I mean the percentage of glowing, the brightness, if the less amount of brightness, so what will be in that case, the T on should be less than T off. Okay, so this is the kind of feature the board has, and you can use this pulse width modulation to I mean in any defined cases. That I'm giving a particular example for the brightness. So in other cases, for a servo motor, if you want to I mean control the speed of the motor, you can do that by using this kind of pulse width modulation technique. Okay, so in this pulse width modulation technique, so you can see that the analog write is the command, and the pin number from where you can take the output. That pin number you have to specify. That pin may be 3, 5, 6, 9, 10, and 11. Fine. And then what you have to do, you have the total cycle of 0 to 255. So total you have, so this is 0 to 255 volt means this 0 is 0, 255 means 5 volt. So you are, I mean you are branching your total range. So the 50% half of it, that means 220, and what will be 25%, that will be half of this 128, that means 64. So in this way you can achieve the pulse width modulation. Now the serial communication is the another important major concept of this. So the feature of this analog Arduino board is that you don't need any hyper terminal. What do you mean by hyper terminal? You may have seen that for a communication, I mean serial communication or the data acquisition purpose, you need another terminal kind of interfacing, or the sometimes it's also called a plug-in software for the data acquisition. Suppose you have, if you use the Keysight or Agilent data acquisition system, or maybe LabVIEW based NI data acquisition system, you have to use the LabVIEW software for the data acquisition. There is a terminal. That terminal is called the hyper terminal. That hyper terminal by using that hyper terminal, you can the data acquisition can be possible. But here, with along with your software, that software I have shown you, that ID 1.8 version. So you have a side by side terminal window. By that window, you can just take a data, whatever the data is coming from any sensor value or any other where through the Arduino board, you can take the data. I mean, you can save it in your computer or any cloud. So I will show you that thing. So this is the serial communication, and the Arduino board. The Arduino board supports the serial communication. Fine. And this serial communication, when occurs, you will find that when the transmitting occurs, you will find that the RX, the LED, this RX LED will blink, and when the receiving data, when the Arduino board receiving data for in case of sensor, and when the Arduino will transmitting the data, you will find the TX LED will blink. Okay. And there are some other commands are available there. There is serial begin, serial print, serial read. We'll make a example with the serial begin also. Now come to the sensor and actuators part. There are several sensors are available ready to use for the Arduino board, and I mean there are universal, there are versatile. You can use, if you buy it, you can use for any board, starting from Arduino, Raspberry Pi, whatever you want, you can use that, and any version of these boards. So these are from starting from temperature sensor to the ultrasonic sensor, infrared sensor, potentiometer. I mean, whatever you want to use, you can use this sensors with the Arduino board. And similarly, the motors, buzzer, the relay, these are the actuators you can interface with the Arduino board. Now here is the some specific variable. So you don't have to bother about the thing what you are using. I mean what the sensor you are using. You should just write for the mic, the sound, the variable is known as the sound variable, photoregister, light level. So these are the variable, you just put it. I mean you just write it. The Arduino board can I mean automatically understand that okay, if you write the temperature, that means Arduino board will understand okay, there is a temperature sensor, and the data should be taken from the temperature sensor at the point specified in the program. Okay, so as I told you, so let's start the coding. Okay, so coding part. So if you see a program, so let's start the very basic of the program. In any program, any Arduino program is mainly based on the C or Python. Okay, so if you don't know the C or Python, no problem. So just follow it. So in this particular Arduino program, in any program, there are three main basics part. Mainly you will find these two part, not this part, but in a higher level programming or in some complicated programming, you need this define pins variable. You need, for example, here this kind of variables that will be used in this part. So what? So let's start with. So first, hashtag define. Has define means you have to define the variables. Okay, define pins with variables. Fine. In which pin you want to take the data. Next part is very important. This void setup and voice loop, these are the very important part. You have to use these two part in your program to run a program or compile a program and compile the to successfully compile a program. Okay, so in void setup you will find there the defined pin as output and input using pin mode, as I told you. So using this pin mode, what we will tell the 13 comma in 13 mode you want this is the pin and in this pin what you want to do, digital write, digital read, whatever you want to do, you have to specify. Now next part is the loop. Void loop is this part is important for the control. What you want to do? For example, you want to blink a LED for 1 second. So for that purpose, you have to write a program. So whatever you want to do, you have to write in this void loop part. So this is the main basic configuration of your Arduino programming. So now once again come to the part. So if I go to if you see that, so we have a void setup. Okay, and here you can see void setup, then first bracket, and this second bracket will tell you that okay, the pin mode is coming. The pin mode 13 means in 13 pin we can get a output. Okay, now here you can see void loop, the loop part. This is a kind of programming for LED that should be on for 1 second and off for that should be blink for blinking a LED for 1 second. So that is glow for 1 second and that should be off for 1 second. So that is the programming for that. I will describe it. Before going to that, I want to give you some theory part of it. That is a syntax. What is the syntax and what is the theory of behind this programming? So this syntax, the Arduino program, is consist of letters or words and symbol known as tokens. Okay. For example, if you can see that the the pin mode command has total 7 tokens. Okay, the pin mode is the name of a function that tells our program to run some code written elsewhere in Arduino. The parenthesis, you can see this parenthesis. Uh, this is I mean this means our tokens that enclose, I mean that is defined by the pin mode function, and the input known as the argument consists of number 30. You can see that this, and if you the output is the special keyword in Arduino in the pin mode function that uses to determine which pin it should control and if that pin should be an input or output. If you get, instead of writing input, if you write input, that means in pin 13 you will get a input data. So you can notice that the arguments that are separated by the comma, this kind of comma. So there is a comma and semicolon. If you see that this comma, this comma, that's this is the another token. So these are the two tokens, number 1 tokens and number 2 token. So in this case we can have maximum of 7 tokens. So tokens are separated by the comma. Finally, we have the semicolon. Okay, and this semicolon is a special C token which is used to denote the end of a command, and it is known as a statement terminator. These are the theory part. Okay, now the compiler that program converts our code to machine code looks for semicolon to determine whether, I mean, where the statement ends. It doesn't care if statements are on the line or in the main line. So if you if I don't write the semicolon over here and I I mean delete it and something like pin mode 14 comma input, or here something like that, then wherever I put a semicolon, the compiler will just look at the semicolon and it will search for the semicolon, and to, I mean and then, because this is a statement terminator, so wherever the compiler get the semicolon, it understand that the statement is terminated. Okay, it may be single line or it may be multiple line, it doesn't matter. Whenever it will find the semicolon, that means the program, this command is terminated. Okay, or the voice setup, this part of voice setup loop is terminated. So then you can see some slashes or slash asterisks. These are the thing, I mean, whatever you will start by typing a slash asterisk, then enter whatever text you can write there and type, then you can type this, so this part is double slash or star asterisk, whatever you will write. So this will not consider by the compiler. So what that mean, you can, for your reference, so that means, for example, digital, so here you can see that, so slash, the setup function runs once when you press the reset power. Okay, so now slash initialize the digital pin 13 as a output. So these are for your reference, for understanding, nothing else. If you don't want to write it, don't write it. But if you come after 1 year, 3 years after, so you can understand that, okay, this line is for this line is for this, so nothing else. So so what does it mean if you slash stars slash asterisk or slash slash, that means the compiler will not run this line. Okay, so that is for your purpose. So that is for your understanding. You can write these things. So initialize digital pin 13 as a output. So that is the command for this. Now the loop function runs over and over again forever. So you can know that because there is a void loop and there is a third bracket, and so this loop will runs for forever. I mean, this is a kind of loop. Okay, so now let's come to the program directly. So turn the LED on. High is the voltage. High is the voltage for making 5 volt, and low is the making the voltage for 0 volt to pin number 13. So if I give you, I mean, so let's start with the program, direct programming, so it will be understandable for you. Okay, so pin number 13 you can see. So I am drawing. So let's take a programming. So in pin number, so what I have written, void setup. This, so this is mainly for the port. So pin mode 13 output means, so this is the 13 and here is the output, and here what is the programming? Make a program that makes the built-in LED blink. You have a LED and you want to blink it. So you have the LED and you have connected the LED to the pin 13 and you want to blink it for 1 second interval. That is our nothing. So I have defined the pin mode 13 as a output. So Arduino will give the data to the output. Now come to the void loop, where I have a control, and void loop part I have to write the program what you want. So digital write means what? Digital write means, as I told you, write something data to that pin. Which pin? That pin is 13. And what we have to write? The high. High means what? The voltage. Which voltage? The maximum voltage. The 5 or 1. 5 volt 1. So whatever the power rating or the current rating of this, mainly the current rating is 20 milliampere of this particular pin. So you have to make, so what the command means? This command means you have to write the data in pin 13 in high. High means you have to give the value 5 volt or 20 milliampere or simply 1. Fine. Now next line, come to the next line. You can see that the delay. Can anyone confirm that I am audible to you or not clearly? Sometimes there is a
Audible.
network problem. Okay,
Yes,
fine.
sir.
Audible,
So
audible.
now next come to the next line, that is delay. Delay 1000. What does it mean? So what was our aim? Our aim was blink the LED once. So that delay 1000 is typically for the 1 second. So this thing you will understand, you will when you are going for the programming, you will easily understand. Is all these programming are available in the GitHub. There is a very well known site there. This GitHub is for several programming related, not only for Arduino, Python, big data, whatever you want. Machine learning, whatever you want, you can get the very basic understanding, basic programming of any kind of your problem, any programming related application. Okay, so this delay 1000 means, this 1000 means 1 second. Okay, 2000 means 2 seconds. So digital light means 1. So write, so you are commanding the Arduino to write a digital data in pin 13 high for 1 second. Fine. So your LED will glow for 1 second. Think it is clear. Now come to the next line. So digital light 13 low. That means low means 0 or whatever the lowest voltage you can give, 0 volt or 4 milliampere, whatever you want to give. On your LED of your LED for the one second. Very simple. Don't have to bother it. So this is the port. From here you can connect your USB to the your PC or laptop and plug it and play. Very simple. And most probably in next 5 years it will be in 10 to 10 plus 12 courses, because this is very easy. The student can easily learn with this, easily play with this kind of boards. And as I told you, nowadays if you go want to buy a Arduino board, it's simply around for high end it may be 1,000 rupees. For low end it may be around 200 to 300, not more than that. So very easy is something like that. Now come to the another part of this, features of this. So you can write any kind of program. I will show you the program in video. So now come to the another part that is important for this Arduino. There is a serial monitor. As I told you, you for the Arduino programming, Arduino serial communication, or the data acquisition for the Arduino, it is very easy, and you don't need any hyper terminal. It has it will inbuilt provide a this kind of terminal. Whatever you want to write, or whatever you want to take the data from any sensor, you can do it by using the terminal. There is an option is there for the serial communication in this part. If I click that here, can you see that the serial monitor? So by clicking on the tool, if you click the serial monitor, so automatically this window will appear. And for that purpose, what you have to the specific, you have a specific command you have to follow. So this serial begin, it is the beginning of your serial data. This is a very common command. And 9600 is your baud rate, and this is fixed for the serial communication. This is called the baud rate, and this rate is fixed for the Arduino board. So don't bother about it. So this is, you have to use over and over again for any kind of serial communication by using this Arduino board, and that is fixed. So this is void setup loop, and then this is the void setup, and then void loop. What if you want to print a serial print? So this is serial dot print, this is a command, and you want to print hello world. See, and with a delay of 1 second for continuously. So this hello world and so on, this will actually fill up your all window, and you will see this the continuously will come in your serial in this window. Fine, very easy. Similarly, if you want to print some input, so you input from the sensor, you can also use this kind of. So this will be fixed, this part will be fixed, and you can just modify by using some pin mode command. So by using some pin mode, there are available there. There's a many example, several examples are there. I will show you. I will also, I can share that video with you. So okay, so I have this. Okay, I just forgot that. So see, this is fixed. This is for the sensor data acquisition. So this is fixed because 960 is the baud rate of the Arduino board. This is fixed. Now see, so this my value random 100, the random. So you want to take the 100 value. You have fixed it. So this is fixed. So the value is this serial print my value, and okay, this is kind of not data equation, sorry for that. So you want to print some random value within 100. So my value, this is a variable, this is known as the my value is the variable value is equal to random 100. That means this is a kind of C programming. So this is also called as the variable. So when you are learning this thing, you will automatically understand the thing. So what you have to understand, as I told you, that is the basic, I mean, skeleton of the programming, nothing else. So these variables you can find the library, or if you search it simply in Google, you will get the command. But you have to understand the skeleton of the program. So serial print, the my value is this, and serial print in. So my serial print in means the my value will be print over here, and that should be within 100. See, so my value is 73. Whatever, I mean, this will come randomly for infinite time. So thank you for watching. So these are all about Arduino board. I will insist you to go through the. So I think I mean it is to understand that you don't have any Arduino board in hardware, but you can do that. You can make a project on the Arduino. There is a very well-known software is there. I will show you a video on this right now. So that's named as the Thinker TH. You can search it in your website also. Thinkercad. I will show you a video on it, how to use the Thinkercad. It is very easy. So that is the kind of simulation board you have. So you have an Arduino board, you have a sensor. I mean, all these things, all the other, I mean, the programming you have, programming window you have, and you have the same compiling things, and you have the simulating options. So you can simulate it. You can see the result at the same time. So the assignment for you should be, you may submit it my mail ID. I'll share it. So my request is to at least take your own choice and make a system that has a sensor. So assignment should be something looks like this. If I write, make a, not make, it is not sound well, design a system with a combination of a sensor and actuator. You can choose any, whatever sensor you can choose. You can choose by any I mean defined kind of actuators are there. You can choose any one of them, but that should be in specific application. For example, so you have a boiler and you have a temperature measurement over there, and you have a furnace. So what you want to do, if the temperature is exceeded some setting point, so you have to shut down your furnace by something, what, by some relay switch, or or anything else. So this is your temperature sensor, is your sensor part, and actuators is your relay switch to shut down the furnace. So similarly, you can choose your application, and the design concept should be something like that. That should be one sensor, there should be one sensor, and there should be another actuators. Okay, so let's start with the software, how to use that software. I will show you by using a video. Have a nice video, very simple video for that. Just a minute.
Hey everyone, welcome back to the third video in the Arduino series. In this video we're going to be adding in a servo with our Arduino Uno. Hey everyone, welcome back to the third video in the Arduino series. In this video we're going to be adding in a servo with our Arduino Uno. So to get started, head over to tinkercad.com/circuits and go ahead and begin a new circuit. The first thing we're going to need is an Arduino Uno Rev 3. So grab one of those from your components, as well as a servo and a breadboard. So have all three of these components in place. Now the servo is a special kind of motor, let's say, that has the ability of rotating, but only between 0 and 180 degrees. So it can go in both directions, back and forth, but it can't spin in a full 360. If you hover over each of these leads, you'll notice you have a signal lead, a power lead, and a ground lead. So simply connecting these to the Arduino would be fine, but since I want to give you all more experience with the breadboard, we're going to be using the breadboard and then connecting them to the servo itself. So starting with the ground, I'm going to take that and plug that into the negative port here. So all this is now considered ground. I'm going to take the ground and plug it into the ground on the Arduino. As for the power, that needs to go into a 5-volt source. So I'm going to take that and I'm going to plug it into the 5-volt, but I'm going to plug it in like the following way. Since we don't need the ground, I'm going to take that and plug that into the negative port here, connecting them to the servo itself. So starting with the ground, these components in place. Now the servo is a special kind of motor, let's say, that has the ability of rotating, but only between 0 and 180 degrees. So it can go in both these components in place. Now the servo is a special kind of motor, let's say, that has the ability of rotating, but only between 0 and 180 degrees. So it can go in both directions, back and forth, but it can't spin in a full 360. If you hover over each of these leads, you'll notice you have a signal lead, a power lead, and a ground lead. So simply connecting these to the Arduino would be fine, but since I want to give you all more experience with the breadboard, we're going to be using the breadboard and then connecting them to the servo itself. So starting with the ground, I'm going to take that and plug that into the negative port here. So all this is now considered ground. I'm going to take the ground and plug it into the ground on the Arduino. As for the power, that needs to go into a 5-volt source. So I'm going to take that and I'm going to plug it into the 5-volt, but I'm going to plug it in like the following way. Since we don't need the 5 volt anywhere here, I'm going to click once, click again. I'm just kind of clicking to create those arcs there, to create some nice connection there. So that's going to be the 5 volt, and because that is providing the power, I'm going to change that to red, whereas since these are the ground wires, it's just usually good practice to keep them black. And then lastly, we have a signal wire. So we're going to connect this into port 9. And there's a specific reason for port 9, which I'm going to get to in a second. Let me kind of navigate myself around there into the signal wire. And because it's a signal wire, you are free to choose the color you want to. Okay, so to get started about why I plugged it into 9 and none of these other ports over here. The servo runs in a very specific and special way. These are all digital ports over here, so everything really between 0 and 13 are considered digital ports. Now we will stay away from 0 and 1 for specific reasons which I'll get into later, but all of these are digital, which means digital ports can have either a 0 or a 1 signal. Okay, that means it'll either send a 0 or a 1, or it will receive a 0 or a 1. So you either have everything happening or you have nothing happening. So what that means is you either have your light on, which would be like a 1, or you have your light off, which would be a 0. Another way to consider this, we could also call it low and high. When you have your signal as high, it means it's on. When you have your signal as low, it's off. But these are the number equivalents. Now, I said the servo can move anywhere between 1 and 180 degrees. And if it did move between 1 and 180 degrees, there's no way we can receive a number within this range if all we can receive back from a digital port is 0 or 1. However, there are special ports, special digital ports, the ones with these little tilde signs over them, so 9, 10, 11, 3, 5, and 6, that have those little tilde signs, that are special digital ports that contain something known as pulse width modulation. This essentially then turns your digital port into an analog port because it's varying the time of the on signal and the off signal to create a value, and then you can use that value to control things. So we can create the value of 0 to 180, even though in reality this can only go from 0 to 1 based on how often we turn on and off the signal. And because Arduinos and computers can do this, thousands of times per second, if not faster, then you won't even notice that it's doing this. Okay, so we've plugged it into 9. We got everything else plugged in. I think it's ready to code. So let's go ahead and head over to our code. And this is like a new interface for me. It's usually down here, but I'll work with it. And I'm going to go ahead, take the code that's in it right now and toss into it. And for this, we're going to also need to create a variable. So start by heading over to variables, and we're going to create a variable, and I'm going to call it position. So type that in, press OK, and now we have a position variable that's going to allow us to move or adjust the position of this servo. Now, what this program is going to do is it's going to allow us to turn this 180 degrees back and forth, and we're just going to have it on a time loop so we can just simply see what the servo can do. To do that, we're going to have to first count up, and then we're going to have to count down. Go to Control, look for the count function. I'm going to take one of those, drop it in there, and then head over to the output. And because we're going to be adjusting the servo, you want to select the one that's discussing the servo, and this one over here is the one we're looking for, rotate servo to a pin. And I'm going to grab a second one of these for later because we're going to need one for our countdown function. Okay, so let me try to adjust this a little so you can see it better. Kind of limited based on how this is set up, but I guess I'll just roll with it for now. So what do we have? We have count up. We're going to start at 1, and we're going to move from 1 to 179. Even though this can probably go to 180, I'm a little concerned that that 180 value might reset it and cause it to spin. So I'm going to have it count up from 1 for position. So position right now doesn't have a value. We can set it to 0 if we'd like. We're going to have this count up by 1 for head and grab this here, drop that in, and I'm going to say set position to 0. Okay, so position, the word position has the value 0 in it. Just like in math, you can say x is equal to 0. We're just saying position is equal to 0. And then we're going to count up by 1. So the first time this runs, it's going to be position is equal to 1. And then we're going to rotate the servo pin, and we plugged it into digital port 9. I'm going to adjust this then to 9. And we're going to make it move position degrees, because we just said we counted up 1 for position. So position is at 1 the first time this runs, and then we're going to wait 20 milliseconds. So I'm going to put that in there. I'm going to type in 20. I'm going to adjust that to milliseconds. Okay, now the cool thing about this count up loop is that it's going to keep counting up. So it starts at 1 and it moves this 1 degree, then goes to 2, it moves that to 2 degrees, so on and so forth. Once position is equal to 179 and it runs that, then it's going to break out of this loop and it's going to go to whatever is underneath it. So at the end of it, it's going to be equal to 179. So over here, I'm going to go over. Actually, we don't need to set it because it's already at 179. I'm going to grab another count loop. Okay, I'm going to count down by 1 for position from, and if we're at 179 right now, I'm going to say 179 to 0, or to 1 if you'd like, because it will be at 179 and then it'll go down to 178 every time it runs this loop, and it'll continue to do that until it hits 1, and then after that it goes back to the start of the program and positions back to 0 again, and then it continues on and on. So it goes back and forth. Let's go ahead and just start the simulation so you can kind of see what's happening here. So it's rotating from 0 to 180, and then it goes back. Okay, and you can definitely see there's kind of a kickback almost, but it's rotating and then moving back. Okay, so that's pretty much what this program does. If you set this circuit up in real life and you want to get the code, remember you are able to extract the code out. You just need to go over to where it says blocks and switch it to text. Up in real life and you want to get the code, remember you are able to extract the code out. You just need to go over to where it says blocks and switch it to text. And then I guess it's saying, are you sure you want to close the block editor? Any blocks you have will be lost. That's fine. Press OK. And this here is the code that you'll want to copy and paste into your Arduino program. So copy, paste it, and if you are having issues downloading it, check back to the second video because I talk about it in the end about how to import it correctly. Okay, and you can always switch back to blocks if you'd like, unless it deletes the blocks. So that's good to know, and I'll...
Welcome back to our STEAM class. So in this exercise 1.2, we'll be doing some simple Arduino coding. So now, again, it's time to create a new circuit. So again, on the new circuits, you go to the top left corner and enter exercise 1.2 and then press enter. Okay, remember to do that so that your file name will be exercise 1.2 so that it will be easier to find. Now, since we will be doing Arduino, so it's time to key in UNO on the search bar and then bring in Arduino Uno R3. So today we'll focus on using this board to do some basic function. So this basic function that we'll be doing will involve, again, light bulb. The key in bulb, drag in your light bulb. Now, we'll focus on using this board to do some basic function. So this basic function that we'll be doing will involve, again, light bulb. The key in bulb, drag in your light bulb. Now, to use the coding function, remember that we have to use those 0 to 13 and A0 to A5. If you look clearly, over here, the 0 to 13, it says something that have digital, and then PWM with a symbol over here. It means that 0 to 13 are all digital, and then the one with symbol can do PWM. Okay, and then A0 to A5 are analog. So we're gonna do digital. You will see the words digital again later. Okay, so digital means that you can only turn it on or off. So you either have on or off. You couldn't do any other number. So it can be very easily used to turn this light bulb on and off. So the very first thing I want you to do is that you look for the number over here, 0 to 13. Okay, if you feel that it's very hard to read it sideways, you can actually rotate it, okay, so that the number are upright. So for this exercise, we look for number 5. Okay, if you put over here, it will say D5. You click on it, and now connect to the light bulb. Like what we say in previous exercise, light bulb doesn't have any polar, which means the positive and negative are fine on whichever way you connect it. And again, from last exercise, we say that, let's say if number 5 is provide electric current into the light bulb, we need a way for it to go back. Okay, so for the current to go back, we use another terminal, connect it to the ground that we used in last exercise. Now this is complete. This is a complete basic circuit that connect the light bulb to number 5 and then back to ground. The next thing you need to do is to do the coding part. So you need to go to the top right corner and click on the code that we have seen last week. You need to delete the built-in code first. So you click on it, drag it around, and bring it to the rubbish bin on the lower right corner. Now, to turn pin 5 on, over here, if you look around, you have a lot of different functions similar to your M block. Over here, there's something called set pin 0 to hide. This is the one that we need to use. So you drag this one and then put it on the workstation over here. It's actually the coding station over here. Then you click on this arrow and choose number 5 that you have connected over here. So these two numbers have to match. That means if you connect it to other number, you have to change the number to this one as well. Now if you go to the top right corner and press start simulation, you will see that it light up. Okay, this hide over here means that turn it on. Okay, if you press stop simulation now, change it to low, you press start simulation again, it won't be lighting up because low means turn it off. So what else can we do? Once you press stop simulation, now you come back to the code block over here. Okay, you look for the control beside output. So it's just right over here. Okay, click on it, and then there's something called wait 1 second, similar to what you have in M block. You drag this wait 1 second over here. Okay, change this to hide again. Right click on this set pin, press duplicate. You'll see that it gives you another set of set pin and wait. You now stick it at the bottom, click so that it's snapped to it, so that you have a connection of 1, 2, 3, 4 block that says set pin 5 to hide, wait 1 second, change this one to set pin 5 to low. Alright, and then wait 1 second. Now if you press start simulation, you will notice that now the light bulb light up for 1 second, stop, it's go off for 1 second, then on again 1 second, off 1 second, on 1 second, off 1 second. So basically we are using this code similar to mBlock to program our Arduino Uno to control the light bulb. So this is a very simple demonstration on the capability of Arduino Uno in terms of controlling circuits. That's for exercise 1.2. So today conclusion, we can use things.
So I think you can understand how to use the Thinkercad. Just you don't have to install it anything if you don't require it. So just go to Google search. You can find the Thinkercad, and there you will and you can just use the Thinkercad if you have the internet. You can use it in online browser also. It is very easy. You can use the different video in web. There are several videos are there in the YouTube. You can use that to understand the programming more detail, and very easy. You have to, it's a kind of block game. So whatever if you understand the thing, you just add the block by block, and the code will automatically generate. Okay, it's very easy. So let's do that. I will also share one 30 minutes video how to interfacing this Arduino with how to interface the sensor with the Arduino using this Thinkercad. So I think that will be helpful for your assignment also. Okay, if you have any question you want ask me. Otherwise, thank you for your time, and
Sir,
thank you. Yes,
can we use ESP32 because of
yes,
can we
yes,
use
please.
ESP32?
I can hear you. Can you please be louder?
Sir, can we use ESP32 sensor in place of
Hello.
Arduino? You know,
Can we use? Hello. Can you please repeat?
sir, can we use ESP32 sensor in place of Arduino? You know?
Yes, yes. ESP32 is, we can use that. So do you want any video for that?
Sir, actually, in this semester only, we have a separate class of cyber physical system where we created a cyber physical system for collecting data using DST11 and ESP32 for temperature and humidity.
Yes, we can do that. We can do that. That is a very using example. I have the 30 minutes DHT32 and the LoRa board. Whatever you want to interface, you can do that. Whatever the
Okay, sir.
sensor we have under the PR sensor, PIR sensor, gas sensor, temperature sensor, there's a relay, whatever you want to programming, you can do that. By my request is to that just first use the Thinkercad, because this is not first you don't know the, if you don't know the Arduino, you don't know about the programming also. This is a very basic. So just block, but you can understand the block as I have shown you in the video. So use the block to understand the thing, and that will be more easier for you also to build the code, because if you compile the program, it will be automatically the code will be generated. So and you can see the simulation of it as I show you in the servo motor. So similarly in other also, for the LCD, for ultrasonic sensor, all the simulation result, whatever you will find, that whatever that will do in what that will happening in real life time by using the hardware, the same thing you can feel using the software also. So that's why I give you that assignment. So you can use the DST32 sensor as well as some relays to develop your project. Okay.
And sir, whatever code will be generated, it will be in C or Python.
Yes, this is C. Very simple C. The code I have shown you, that is mainly basically on C. Okay.
So, can we use Python as a coding language?
No, that is the not, you can't use the Python over here. C has sometimes used, but that is not supported by some, I mean, or not, that is not supported all the variables. So as we know that C is very simple language, as well as the variables over there. Variables means the different kind of application, different kind of specific commands for particular application. So that is not available in that Python. So Python you can use. Sometimes people are use Python, but as you know, the programming is not important part of this Arduino. The main thing is you have to do, I mean, you have to execute some project. So whatever language you can use, you can do that. So that's why I giving you the video for the Thinkercad. Thinkercad will not, if you should know, if someone don't know about the programming, so he can also use the, he can also program the Arduino board by using the Thinkercad, because just you have to, he or she has to put the block by block. So what what or he or she want to do, he or she has to put the block by one, and the code will automatically be generated in the background if the program runs or program successfully compiled. Okay. So
Okay.
you can use any kind of programming, but that is not our purpose for this particular thing, because our thing is to execute some problem. For example, you can if someone I mean draw a, you can, take a project that to make a oximeter. You can do a oximeter. I have my student, one of my student working with that. I mean, she also executed successfully, made a oximeter by using the simple Arduino board. Simply you can use some infrared sensor which can sense our body temperature, which are you can see in malls or wherever you will go, you will see that kind of infrared sensor. So these are the very basic things and you can use it. So main thing here, you have to execute some our project. So programming is not important in there. Okay.
Okay, sir.
Okay, fine. So thank you. Good night.
Okay, sir. Okay, sir. Good night.
Good night, sir.
Okay, sir. Thank you and good night.